I watched him do it.
Alright, so today we're talking about geometric probability. Geometric probability is probability that involves a geometric measure of some sort. So we're going to start out using a lot of area first. Towards the end of class we'll use some length to do it, but it's using geometric measure in some way. So the probability or the formula is number of favorable outcomes over the number of total outcomes. So like I said, that might include a length, it might include an area. So it might include the area of a favorable outcome over the area of the total outcomes. Might include the length of a favorable outcome over the length of a total outcome, anything like that. Looking for the homework? That's the one right there. Any questions on that? Well, then, first of all, we have this beautiful coordinate plane. It's got 3 shapes on it. We want to find the probability of landing in the parallelogram. Well, first of all, which one of those is a parallelogram? The crooked one. The crooked one. This one right here?
Yeah.
That is our parallelogram, yes. So, that is our favorable outcome. Landing in that parallelogram is our favorable outcome. So what we need to do is we need to find the area of that parallelogram. What's the formula for area of a parallelogram?
We're supposed to know this?
Like
Yeah.
No idea.
Not length times width.
Height times width.
You're getting closer.
Height times width. Can you say it one more time?
Height is correct.
Yeah.
It's just height.
Height times,
Length.
well,
Width.
different word for length, because we don't really have a length here.
Height times.
Starts with a B.
Base.
Base. Base times height. Area equals base times height. Alright, so our base of our parallelogram. 1, 2, 3, 4. Times the height of my parallelogram. 1, 2, 3, 4, 5, 6. So the area of my favorable outcome or my parallelogram is 24 square units if you care for it. Calculate the area of the grid. Well, the grid is a square. Did anyone count the number of boxes on it?
Units. 400.
There are 20. 20 by 20. So 20 times 20 will give us
400.
400. So I'm going to take my favorable outcome, which is that parallelogram, and put it over the total outcome, which is the whole grid. 24 over 400. 2 ways you can answer it. You can answer it as a fraction. Just make sure it has reduced, please. So, what is that? 3 over 50. Or you could write it as a percentage. In this case, it's 6%. So the area you hit, or the probability you hit that parallelogram is 6%. I guess I would also accept the decimal if you want to write it as a decimal. That's fine too. Okay? Questions, comments, concerns? Alright, same question except now instead of the parallelogram I want to find the trapezoid. Probability of hitting a trapezoid. Gabby, which one's a trapezoid?
That one. Next to the circle.
Next to the circle. I'm really glad you didn't pick the circle.
Oh yeah. It looks like an ice cream. It looks like a cup.
More like a trash can.
A flower vase. Yeah.
Maybe, yeah. So the trapezoid's right over here.
Yeah, that one.
So same thing, that's my favorable outcome. Hey, what's the area of a trapezoid? Its formula. This would be a really great candy question.
Base times height.
Not basic thing. What do you say?
Divided by 2 or something like that? No.
That's a triangle, JJ.
Isn't it something? It's like split in half or something.
There is divided by 2 in it, Jack.
Base 1 plus base 2 divided by 2 times height.
Perfect, so it's the average of the 2 bases.
And
Base 1 plus base 2 divided by 2 times the height. Average of the 2 bases times the height. So calculate the area of that trapezoid. My 2 bases. Bottom base comes out to be 4. Top base comes out to be 8 if you count the squares. 8 plus 4 divided by 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 8 plus 4 is 12, divided by 2 is 6, times 11 will give me 66. What's the area of the grid? It should still be 400, right? It's the same grid. It's 20 by 20, so 400. Well, area of the trapezoid is 66 over the area of the grid of 400. Gets me a reduced fraction of 33 over 200, which is the same as what percentage? 16.5 or 17% if you rounded it.
Are both answers acceptable on the test?
If it tells you to round to, no. If it doesn't tell you to round to, then they'd both be acceptable. Alright, any questions? Alright, well let's look at just some shapes now. So not on a coordinate grid, but just some shapes. Circle with the radius of 10 centimeters, placed inside a square with a length of 20 centimeters. What's the probability that a dart thrown will land inside the circle? What's the favorable outcome here? What do we want to happen? What?
Favorable outcome is that it's in the circle.
That it's in the circle. So my favorable outcome I'm going to do is I'm going to find the area of the circle. How do you find the area of a circle? Pi r squared. So pi times, my radius is 10. 10 squared. So it's going to give me 100 pi. I'm going to leave it in terms of pi because I don't want any of those nasty decimals. Okay, so leave it in terms of pi. A lot of times when we do the geometric probability, we're going to leave it in terms of pi so we can reduce it later. Area of the square is going to be my total, right? The square is the outside shape. So that has a length of 20. 20 times 20 will give me 400. My fraction will reduce to pi over 4. Right? Take 100 out of top and bottom. What do you get for a percentage, Ty?
Yeah, I can't hear you. It's
Yeah.
78%. 79%. 79%? What is it?
I'm
79%?
trusting on you guys.
I think it's 79%.
It's 78.5, but if you're not in, it's 79.
Calculated that.
Glad you can use your calculator, Ty.
Thank you.
79%. Alright. Guys, any questions on that? Alright, one more of these type problems. If a square with a length of 15 inches is placed inside a circle with a radius of 7.5 square root of 2. So these are 15, radius 7.5 square root of 2. What's the probability that the dart thrown will land inside of the square? Well, JJ, what is my favorable outcome here? What do I want to happen?
The area. Oh, no, area of the square.
The square, right? We want to land in the square, so we're going to find the area of the square. Well, area is length times width, 15 times 15. Gives me 225. Colin, what's the total outcome? What's the whole thing, the outside of it? What shape?
The circle.
The circle, right? We want to find the area of the circle. That's our total outcome. Well, pi times 7.5 square root of 2 squared. Should come out to about 112.5 pi. If you got 15 pi, you didn't use your parentheses correctly. Well, if I reduce that, I get 2 over pi. Which comes out to about what percentage? Anybody? 64? Alright. 64%. Any questions? Alright, let's try a little more challenging problem. What's the probability that a dart thrown at the board will land anywhere inside the middle circle, the blue region on the board? I'd maybe shade that part in on my circle, since yours isn't colored like mine is. Right, we want to land in that blue region there, but not the bullseye. The diameter of the bullseye is 4 centimeters. The radius of the middle circle is 6 centimeters. The radius of the outer circle is 10 centimeters. how can I find, my favorite outcomes is blue part, right? We said that, we want to hit the blue part. How do I find the area of that blue part, Ben?
You take the area of the blue part and you subtract the area of the red part.
So we take the area of this whole big blue circle and we subtract off the area of our bullseye. Right, does that make sense? Take the area of this circle, if I subtract off the bullseye, all I'm left with is that blue part that I want. That's my favorable outcome, so let's do that. So let's find the area for both those pieces first. Area of that middle circle, that blue circle. Well, it's got a radius of 6, so pi times 6 squared. Will give me 36 pi. Calculate the area of the bullseye. Well, bullseye has a diameter of 4, which means its radius is what? 2. So pi times 2 squared is 4 pi. So how do I find the area of the favorable outcome again? We're going to subtract 36 pi minus 4 pi. Should give me 32 pi. Alright? So that's my favorable outcome. What's the total outcome of this picture here? Someone besides Ben. He's been helping me a lot with this problem. Luke, what do you think? What's the total outcome? What's the total here? What's the big part of our picture? The outside edge.
Oh, 10 times pi squared. No.
10 squared times pi, right?
Yeah.
We're taking that outer circle and we're finding the area for it. That's our total area. So pi times 10 squared, so we have a radius of 10, gets 100 pi. Well, then take your favorable outcome, 32 pi, put it over your total outcomes, 100 pi, reduces to 8 over 25, which is 32%. Good, really good. Any questions on that problem, or any problem we've done so far? No, we're good? Bueno? Alright. So those we were all using area. Now we're going to use length a little bit. We want probability of line segments. So we're going to choose a point at random on line segment AF, right there. Find the probability that is on the indicated line segment AB. Remember, we want favorable outcome over total outcome. What do you think? Nothing? Everyone's looking down so they don't make eye contact with me.
2 over 18.
How'd you do that, Ty?
I took what we're trying to find,
Which is AB.
which is AB, so what is the favorable outcome, and I divided it by the total outcome, which is 18.
Perfect, right? AB has a length of 2 over the total length of 18. So now all we're going to do is we're going to reduce that to 1 over 9, which comes out to approximately 11%. Going right as a percent. Take your favorable length over the total length. Favorable outcome over total outcome. BD is 9 units long over 18 total. Gets 1/2, which is 50%. BF. How long is BF? 16 over 18, which is 8 over 9, approximately 79%.
89%.
89.
Whoa.
Getting close.
So you guys are staying awake.
That's a lie.
Is it though?
Yeah.
Well, guess what? Now you get to do this one on your own.
Cool.
Okay.
Okay.
And I'll pick some random contestants to do it, or to tell me what they got. Israel, can you pick a number for me, please?
6.
6. Lauren.
Yeah.
JL.
4 over 14 or 2 over 7.
4 over 14, 2 over 7. Comes out to what percentage?
29.
29%. Right? JL has a length of 4, total length of 14. Comes out 20%, 29%. Lauren, pick a number for me, please.
3.
3. Braden.
Like, you didn't even count.
Yeah.
You didn't count.
You're right. I just picked Braden. I want him to do it. What's wrong with that?
Why'd you ask her if you knew?
10 out of 14? So 10 out of 14. 5 out of 7. Should be approximately 71%. Kevin, what were you saying?
I said, why'd you ask her to pick a number?
So it makes it look like I did it randomly.
Not really.
Destroyed.
Alright, any questions on that? One problem left. Application problem. We work for a temporary employment agency. Live on the west side of town, prefer to work there. Work assignments are spread evenly throughout the rectangular region shown. Find probability that an assignment chosen at random for you is on the west side of town. Alright, well, what's our favorable outcome here? What do we want to happen? We want to be on the west side of town. You'll notice the west side of town is a really nice right triangle. So if we're looking for a favorable outcome, right, favorable over total, we can find the area of that triangle, and that's our favorable outcome. Well, what's the area of a triangle formula? Length times width divided by 2, or 1/2 base times height. Base of my triangle is 2.25. Height of my triangle is 1.5. Put that in our calculator, what do you get? 1.6875. Alright, Colin.
What?
The total outcome, or the total area. How do I find that?
You add 2.25 plus 1.75,
Okay.
and then you multiply that with 1.5.
Perfect. So add 2.25, 1.75, because that gives us a length. That is 4. Multiply it by 1.5, because our total area is that whole rectangle. Well, 4 times 1.5 will give us 6. So what percentage chance do we get of getting a job on the west side of town? 28%? Sweet. Good job. Any questions?